So today's webinar is going to be on a smarter approach to data replication. It's going to focus around our Replicator product. Kind of its principal role is managing the UDP data streams of flow log, syslog, SNMP traps, things of that nature, and kind of present a model of how it just improves general hygiene in the monitoring space, and gives us a cohesive model for kind of keeping track of those data streams and the health of them, and ultimately kind of minimizing the impact of a configuration and reconfiguration that goes along with monitoring a large network that's providing a lot of flow data or syslog data. So at the top level, what is kind of the main problem we're talking about? It's lots of devices with lots of collection destinations for the different data types, and then ultimately the kind of duplication of that data that we run into incidentally through that. One device maybe needs to send a record to several different systems for analysis or collection. And then kind of in the worst case scenario, you end up with a separate data stream coming from that exporting device and going to each of the destinations. It just causes a lot of extra network usage and ultimately a lot of kind of mess in configuration, as we'll talk about, making it very difficult to make changes to your monitoring infrastructure as time goes on. And then again, just from a very high level, again, we're talking about UDP logging. If you look on the left-hand side, stateful connections are typically not used for very high volume data records, purely because of just the overhead in the management of a stateful connection. UDP is just kind of send and forget. And that really helps, when we talk about flow logging, we're often talking in the hundreds of thousands of flows a second kind of range. Getting the overhead out of the way that a stateful connection has dramatically reduces what's really required to keep those data flows moving at the kind of speed of the observations. So what do we mean when we talk about data exporters in this context? So from the most basic case, we have routers and switches, kind of our traditional flow logs, syslogs for events that are triggered, SNMP traps that might be configured on those devices to monitor some metric. Firewalls and security appliances like NSEL type records, your kind of typical approved, denied, firewall rule inspection. Again, things that are going to be happening at basically line rate that we want to get observations into at very, very high record volumes. Wireless controllers and access points have obviously over the last decade become kind of a very popular place to get visibility into. And again, in many cases, depending on what your campus looks like, there might be hundreds or thousands of devices that are connected into these, again, generating extremely high volumes of flow and logging records. Servers can kick this stuff out as well. It's going to be more along the line of the SNMP traps and syslog. You can configure flow from a few different Linux kernels now, which is becoming interesting very quickly. Security tools and IDS, your Suracatas of the world, things like that, can produce flow records, again, adding to this UDP data stream that's going to be on your network. And then ultimately proxies and web gateways and other things that are just going to have events kick off and have a kind of one-to-one relationship between that event occurring and a data record needing to go into your monitoring infrastructure. So configuration really is one of the main components of why using a tool like Replicator is going to be impactful. In this example, I just did the little piece of a flow configuration where you actually pick your export destination. As I think anyone that's worked through this knows, there's quite a bit more to that. And then ultimately, in an environment that has tons and tons of exporters, these configurations need to be managed on each and every one of them. So in this case, there's 2 export destinations. That means this device is going to be kicking off 2 data streams to 2 separate collection or analysis locations, literally meaning that for every entry in its flow cache, 2 records need to be sent out onto the network, immediately causing duplication, immediately causing more utilization for your monitoring use case than is going to be necessary. And then at the bottom, there's just kind of a basic example of a syslog export command. Again, something that would have to be entered on each and every device. So ultimately what this leads to is lots of devices with lots of configuration that needs to be applied. And then this kind of tangled web of data streams coming out of all of the exporters and then going to each and every one of the individual collection endpoints. So in just this high level graphic, we have obviously our exporters, our UDP flow or syslog data streams. the actual replicator itself, and then the collection side of it, just to give a high level overview of kind of what we're talking about. So ultimately, what this model moves everything to is a single location where all of these exporters can be configured to export their data to. A single copy of that data really being kind of the main use case in deduplication. But what's very powerful about this is it gives some malleability to your monitoring infrastructure, where any change that happens up the stack on the analytics and collection side of things isn't dependent on making a change to each and every configuration on all of the exporters. It's quite labor intensive. It takes a lot of time. Honestly, logging in and making kind of running config changes is always just an interesting thing. For, flow configurations is a safe thing to do even on an online device, but nevertheless, a lot of compliance and kind of change window requirements will often require a lot of overhead administratively to actually go into these devices and make that change, probably during a non-convenient hour, things like that. So in this model, the real goal is to go in and configure those devices to send to a single IP that will be the replicating device, and then allow the replicator to handle the rest of the distribution of that data upstream to your analytics and collection stack or your SIEM or whatever's collecting the syslogs. So ultimately now any change, any product changes, any network topology reconfigurations on the kind of management plane of the monitoring side of things is no longer dependent on going back and reconfiguring all of these devices to acknowledge that change. They're already configured to go to the replicator, and then a change in our replicator profiles, which we'll talk about in a minute, can ultimately redirect that traffic to the new monitoring and analytics destination. So within the replicator, things are organized into profiles. So each profile can take data in from like a CIDR definition. Those can be included or excluded, and a port. So if some subset of the network is going to send its UDP flow and syslog data in on a certain port, that can be put into a profile, and again, included or excluded, allowing for some pretty granular control around which data is going to be accepted into that profile. And then once that data comes into the profile, it can be exported out to a list of collection endpoints, as well as a rewritten port if those analytics or collection platforms are expecting the data to come in on a particular port. So it really gives us a way of shaping the traffic from, again, that replicate, that single IP, that single configuration endpoint, and moving the data around between our monitoring resources as we need. What becomes really powerful, and I work as an engineer on our data science team here, what becomes really powerful with doing this as well is the ability to monitor those data streams themselves. So the replicator has an idea of what exporters are sending to which profiles and can alert when those exporters maybe stop sending data when it, during an unexpected case, or as we'll see, if any collector goes down. Each profile is actively checking the port that it's configured to send to make sure that device is actually up and available. And what becomes really powerful around this concept is the replicator can then alert you to any problems in that data stream. So from a data science perspective, imputation is the process of kind of filling gaps in data, and it ultimately, kind of destroys the quality of analytics. So at least being able to enumerate the periods of time when a data stream has an issue in it, or there's some gap in that data, allows that data to be removed from the analytics rather than just kind of assuming averages or typical imputation techniques that otherwise, aren't going to really be helpful. There's really no imputation technique that would contain an anomaly that many of these things are looking for. More often than not, you kind of end up filling those gaps with just kind of the average behavior of something, and it ultimately erodes the quality of that data. So a very powerful part of the replicator platform is, again, being able to have insight and real-time insight at that into any problem in the data stream for your flow logging or syslogging or whatever, the actual content is. But again, just being immediately aware that there's a problem in that, so someone can kind of go out, figure out what's going on, and fix that in order to preserve the quality of the data. Again, from a compliance standpoint, there's many cases where this data is required to have, and there might be a minimum SLA for how big those gaps can be. And again, this will reduce kind of the mean time to resolving those problems and keep everything within compliance. Additionally, the replicator works in a high availability model where a virtual IP is floated between two units that are in active standby. So that virtual IP is going to be the destination for all the traffic that you're sending. The backup replicator, which has all the same profiles and configurations as the primary, is going to be constantly checking that virtual IP and making sure it's up and available. And then the instant that it goes down, it assumes that virtual IP and continues to receive the traffic, keeping any downtime or, again, cases where imputation would be needed in the data stream to a minimum. This really provides the redundancy to keep your data streams full all the time. And again, keeping all of your analytics and monitoring and collection platforms completely informed without any gaps in the data. So from a really high level, the replicator has a complete configuration suite, which we'll look at in product in a moment, as to how those profiles kind of look and how they can be used. Again, the real-time alarming is extremely helpful for making sure that your data quality is preserved and there are no gaps or holes. There's a web interface, which makes it easy for anyone on a team to kind of jump in and just visualize what's going on in these data streams and add and subtract profiles or augment them as needed. Again, making it very easy to change the topology of your monitoring and alerting platform. There is a full API for doing everything that we'll look at in the UI programmatically as well, which again is very powerful for anybody that wants to make lots of rapid changes or have some very dynamic UDP forwarding environment. And ultimately, the main function of it is reducing this one-to-one relationship between exporters and your monitoring analytics platform. Again, having multiple data streams sending the same data out is just ultimately kind of a gross way of maintaining data that is otherwise very important for operational reasons. This gives just a nice, concise topology to how that data moves across the network, and ultimately just kind of improves the general data health of the whole situation. So I just want to quickly jump into the web UI for Replicator. There's only a few views to look at. It's kind of a simple function to kind of stay out of the way, but still provide nice data streams. From a super high level, and this is kind of what you maybe would think of seeing kind of on a NOC dashboard or something along those lines, there's just general usage analytics for what the platform is doing. Just general metrics around how many exporters, how many collectors, what the actual bit rates are moving back and forth, and the overall utilization of the hardware. Replicator is available as both a hardware appliance or a virtual appliance. Kind of depending on the scale of your flow log environment, we'll kind of choose which platform is appropriate. The virtual one is really nice just because it's so easily extendable to kind of pop one of these up anywhere you have virtual resources. But another main view that's pretty powerful is actually being able to see these data flows to really have an idea of what your input looks like to your analytics and monitoring platform. Otherwise, we go out and do all these individual configurations and then just kind of assume that everything's operating as you assume. This gives a nice visual way of validating that kind of what you expect to be happening with those data streams is actually the case and being able to validate how they flow through. Additionally, if you ever have some issue on a collection or analytics platform, whether it's our Plixer One platform or anything that's using this data, again, this gives a nice visual way of seeing kind of maybe where the data is terminating through that stream. There are a few other different views. You can either look at this stuff from an individual stream basis, which is going to look at kind of the per exporter flow through. There is a separate exporter health view. This is where you can see some lines that are red. These are ones that haven't received any data kind of during this session of the replicators running. Additionally, this is where you'd be alerted from a UI perspective around exporters that have maybe dropped out that you were expecting to get data from. Additionally, all of those alerts do provide syslog out, so they're, your SIEM can immediately see when there's a problem in those data streams. There's a collector view. The replicator itself is actually checking the port that all the data is destined to make sure it's available on all the collectors. This, prevents UDP from being sprayed at a destination that isn't currently up. Again, just kind of reducing overall network utilization for something that's not going to be effective. But also, again, providing alerting into, the existence of a problem, on the collection side of the replication stream. And then finally, we have our profile view. And this is kind of what was described in the previous slides. Profiles are again defined with inclusion and exclusion policies that from a network level where you actually want this data to come through. And again, you can have many profiles on a device. So this is just kind of making it very granular as to how you direct the data around. The profiles will be based on an input port. This is just kind of an enumeration of what's actually sending into it. And then ultimately our list of collectors or destinations we want it to go to, and the output port that we want the data to go to for this list of collectors. And then just some high level analytics around, the actual packets in, bytes in, packets out, bytes out around that individual profile, just for, again, high level validation that everything's working as expected. Again, this is kind of a simple concept, but ultimately a very powerful concept when you're running any analytics or collection platform around these types of logs. Otherwise, it's really, you're kind of just trusting each individual endpoint to be your only source of truth around those records being delivered on time. So any problem in that path is ultimately going to kind of obscure that visibility. So this really just gives an extra level of assurance around UDP data streams and further visibility into the kind of the operation of them. So Ashley, if any questions, we can give it a moment. If any questions come in, if you could just forward them along.
Yeah, so we have a few. What types of environments benefit most from using Replicator?
Yeah. So from my perspective, when I've worked out in the field with customers, Replicator's always just been very helpful for high exporter count environments, campuses that have lots of devices, maybe multiple campuses at that, and lots of devices, further kind of multiplying that outward. Again, because it takes quite a bit of labor and time to go and get all these configurations right in the first place, schedule kind of the change windows so we can actually go make changes to the running config on a lot of these things, and make sure that that data is going to all the destinations that it needs to. Again, the more exporters you have, if there's any case where you need multiple copies of that, maybe there's an analytics platform and a data lake and several different destinations. Now we have a high number of exporters multiplied by a high number of destinations, and then just a ton of kind of duplicated data streams happening as a result thereof. So really any place where there's lots and lots of sources of data, having some high level orchestration around those data streams is going to be ideal.
Thanks. Okay, another one. Can Replicator provide an acceptable envelope of performance over time for each data stream? If so, is there any alarming or notification built in to alert an operator?
Yeah, so that's going to focus around some of the things we looked at in the UI, where there are per exporter, per collector, per profile, and ultimately per stream analytics that can be monitored and measured. All of that's available through an API for really granular level monitoring. And then ultimately, there's just some general thresholding for having the replicator itself directly kick off syslogs to alert on those things. But again, everything we looked at today is also available from an API. So you can really make interacting with these data streams as complicated or as simple as your use case kind of requires.
Thanks. All right, we got a couple more. How does it compare to native flow forwarding from routers or switches?
Yeah, so ultimately all it's doing is just some header rewriting. So all of the payload is completely unchanged. So the data that's coming directly off the devices is exactly what your analytics platforms are going to be receiving. Sometimes in this space, people will do some things to augment the data, and then that just kind of turns into a complicated situation where if you have any sort of requirement around preserving records, you're ultimately not getting kind of a clean version of what the routing plane actually kicked out, or your switches kicked out. You're getting some aggregate from in between. So really the goal of Replicator is to completely transparently pass the data through, but ultimately give that mechanism of directing it around the network.
Thanks. The next one is just a question about API. I assume it's asking if there's API compatibilities.
Okay, yeah. So everything that can be done through the web UI, as well as the metrics that are shown in the web UI, are available over the API. So you can pull for that information, as well as actually dynamically change things about those profiles that are in there. So if there's any sort of dynamics that are required for the UDP data stream manipulation, that can all be done over the API for, kind of really fast changes, or time-based or event-based triggers for changing those things.
Like one last question. Can you explain how Replicator supports compliance and audits requirement? Looks like they're in a highly regulated industry.
Yeah, so again, the alerting around kind of the health of the data streams is really going to be the main component for any sort of vertical with compliance regulations around whatever the content of these logs are. Again, there'll be more than likely some SLA where there's some minimal amount of time that data can be missed, or in some cases, there's no tolerance for data being missed, which is the high availability model we talked about, where a virtual IP is shared between multiple units. And if there's a problem on any unit for whatever reason, maybe there's some issue on that data center, some issue with the virtualization resources behind it, the standby unit just immediately picks it up. But ultimately, the alerting is going to be kind of the most powerful part of that. Again, from a data science perspective, I care mostly because imputation of data just, it just kind of makes a rough situation for analytics that are trying to actively monitor those streams. But again, in the compliance space, it would also enumerate those periods of time where a data stream had a problem, an exporter had a problem, or a collection device had a problem.
All right, that looks like all the questions.
All right, awesome. So just some quick follow-ups. We're starting a Tech Talk series where we're going to go into some pretty deep and granular details around our analytics. The first one is going to be on April 15th. We're going to talk about our graph learning engine that looks at the topology of the network. There's a kind of inferred network structure that we get from flow records, and ultimately a kind of simulation of the network is built, and then some graph convolutional network techniques are applied to it in order to evaluate each individual relationship on the network, not only kind of with its relation to how the network's working, but its relation to how its neighbors on the network work and how its neighbors' neighbors on the network work. And ultimately, kind of helps us find the most interesting conversations that are happening at any given point in time. So that talk's going to be primarily around kind of the low level mechanics and the machine learning components of how that algorithm is implemented. So I look forward to that personally. I hope everyone will join. I think that'll be a really interesting talk. Anyone that really likes networking and data science, this should hopefully be a really fun union of those two things. Next, we will be at Cisco Live, booth 1940. Please come by and say hi. We'll have some exciting things to show there and a fun team of people that are excited to meet everybody. So keep that in mind. That's June 8th through the 12th. And again, we're at 1940. Thank you, everyone, very much for joining today. Please get in contact with us to check out the Replicator product. It is really something that is very helpful for managing large volumes of exporters. Again, it works great with our platform, but it works great with all UDP data streams as well. So again, thank you very much for joining and have a great day.